Hi, hello everyone. Alright, now in this video I'm going to be explaining the WAEC quantitative analysis WAEC 2026 possible questions for the um, WAEC 2026 quantitative analysis. Right, I'm going to be explaining that in this video. And in this video I'm going to be showing you how to get or what is the possible average volume of the acid that will be used in that titration based on the information, the memo that WAEC has given to us. Right, we are going to be calculating the concentration of the acid and of the base, and then we're going to see using 25 ml of the base, sodium hydroxide, how many or how much volume of acid can react with such an amount of the base. Now, follow me while I show you this analysis. If you know you've not subscribed to this page, make sure you do that at the end of this video. All right, now let's continue. From WAEC memo, we are told that the acid to be used is H2SO4, that's a strong acid, and the percentage purity of that is 98%. The relative density is 1.84%. That's the relative density, right? And what else are we given there? And the volume is 5.6 cm cube in 1 dm cube of water, right? Now for the base, it's a strong base, sodium hydroxide, 4.0 gram in 1 dm cube. Now these are the informations why give to. Now we know that the relationship between concentration and volume is enshrined in this formula. Concentration of acid times volume of acid all over concentration of base times volume of base equal to number of acid all over number of base, right? I want to get the volume of acid that will neutralize at the end point of that particular reaction. Now, it's possible even without carrying out the titration, we can be able to know how much acid will neutralize that 25 ml of base, that pipette size, right? It's possible. Now, let me show you in this video. And let's quickly dive into that. From this formula, we know that the Na, when H2SO4 reacts with sodium hydroxide, we produce sodium sulfate and water, right? To balance up that equation, this will be 2 and this will be 2, right? So the number of acid here is 1, number of base here is 2. The volume of the base here is 25 cm cube, and we asked to find the volume of the acid, x cm cube. Now, first of all, let's calculate the concentration of the base. Concentration of the base in mole per dm cube is simply equal to concentration in gram per dm cube all over the molar mass. And the concentration in gram per dm cube, we are told that 4 grams in 1 dm cube. That will be 4.0 gram per dm cube all over the molar mass of sodium hydroxide, sodium 2316 plus 1, that gives us 40, and that will give us 0.1 mole per dm cube. Okay, now we haven't gotten the concentration of the base to be 0.1. Now let's calculate the number of acid and the number of base. Remember, in the balance equation between H2SO4 and sodium hydroxide, you have to produce sodium sulfate and water. Let's balance up that equation. So notice our number of base will be 2, our number of acid will be 1 from the balance equation. Now, the main point now, let's quickly calculate the concentration of H2SO4. Now, we know that concentration is equal to mole all over volume. Now, we know the volume to be in 1 dm cube. Now, how do we calculate the mole? Very simple. The mole is equal to mass all over molar mass. We know the molar mass of H2SO4 is 98, but we don't know the mass. Based on the relative density and the volume given to us, we can be able to get the mass because we know that mass is also equal to volume times the density. And the volume is 5.6, right? 5.6 times the density is 1.84. So let's simply multiply that to get the mass. 5.6 times 1.84. That simply gives us a mass of 10.304 grams. But we are told that the purity of this H2SO4 is 98, meaning not all this is present. Not all this is H2SO4. There's some impurities there. So let's take 98% of this. Let's take 98% of this particular mass in order to get the real mass of H2SO4 present in that solution. 10.304 all over 1, and 98 divide 100 times 10.304. So this is a real mass of H2SO4 present. Now we've gotten our mass to be 10.0979 all over 98 divided by 98, which is the molar mass. Now the mole is 0.103 mole. Now let's calculate the concentration now. The concentration is, since it's in 1 dm cube, volume is 1 dm, we simply say 0.103 mole in 1 dm cube. All right, so we've gotten our concentration to be 0.103, our concentration of the base 0.1, volume of the base, which is the pipette 25, number of base 2, and number of acid 1. And let's simply calculate the average volume of the acid that will be used whenever we carry out the titration on that. That's our main point here. So let's simply do that using our CAVA formula to solve. Okay, so let's make VA the subject of the formula here. The formula will be CB times VB times NA all over CA times NB. Now our concentration of the acid, of the base rather, 0.1, volume of the base 25 from the pipette, number of acid 1, concentration of the acid 0.0103 times number of the base gives us number of the base gives us 2, right? From the balance equation, this 2. And let's simply solve all that. This gives me 0.206, right? So 0.1 times 25 gives me 2.5. 2.5 divides 0.06, 0.02, 0.206. That gives me 12.14 cm cube of acid that you must get, right? So this is the average volume of acid that will be neutralized by 25 cm cube of the base, based on the information and the concentration given to us for this year. Now, if you know you've not subscribed to this page, make sure you do that. Share to your friends and have a successful exam coming up. Make sure you prepare and have a nice day.